Look, in this question, what you have been given is there are two devices rating this. Look, what is rating? So let me explain what is rating. Rating simply means this is 22 watt device means maximum energy it will consume, maximum power it can consume is 22 watt, and it can be given maximum of 220 volt of potential difference. Okay, so the battery or the device which you can use to give voltage to this device is 220 volt. Now other is 11 watt means it is exactly half of it. Okay, 11 watt. Other device is 11 watt rating and 220 volt means maximum voltage it can endure, it can tolerate is 220 volt, and the maximum power it can draw is 11 watt power. Okay, are connected in series. Okay, so we have two devices, both are connected in series, and suppose we have given them 220 watt. Okay, so the 440 volt may connected across a 440 volt. So this is very weird question because 440 volt has been given. Okay, 440 volt has been given. The fuse which the two devices likely to burn when switch on. The fuse of which of the two device is likely to burn when switch is on. Okay, both are connected in series. Okay, so let me explain that actually according to question their fuse has been. Okay, there is a fuse. Okay, and then again for this device a fuse has also been used, but actually one thing I would like to tell you that both are in series, so even this fuse burns or this fuse burns, the power supply will cut off. Okay, so this is 440 volt and this is 20 watt 220. So first of all I would like to tell you that this is power and power is simply vi, but there are other equation for power also, like I square r or v square by r. Okay, so we are going to use this formula. Why? Because we have to calculate its resistance first, and we have been given the voltage and we have been given the power. So power and voltage are only given, we can use with this formula only. Okay, so we'll be using this formula which is v square by p. So 220 into 220 divided by p. P is 22. This will simply cancel out, and so we are left with 2200 ohm. So this is the resistance of this 2200 ohm, and for this we'll be using this formula again with this using same formula which is v square by r and 220 into 220. Why? Because v square is there, so we are writing 220 volt two times, and this is power, or this is power. Okay, because we are using this formula, so this will be cancelled out in two times and this will be 4400 ohms. So its resistance is 4400 ohms. Now we have calculated. Now one thing which is worth mentioning here, that we have been given 4440 volt. So some voltage will be consumed by this and some voltage will be consumed by this. So maximum voltage which it can tolerate is 220 volt, and the maximum voltage which it can tolerate is again 220 volt for both. Okay. Okay. So first of all we have to calculate the voltage which it is going to have. What voltage it will have across it? Say it is V1, okay, and say it will have a voltage of V2, okay. So we have to calculate this V1 and V2. How can we calculate? We will have to use V is equal to IR. But what is I? We don't know I. So for the calculation of I, first of all, we know that total resistance is what? The total resistance is R1 plus R2, which is 2200 plus 4400. Okay. So this comes out to be 6600 ohm. Now we have the total resistance, we have the total voltage. We can easily calculate I is equal to V by R using this Ohm's law formula. V is 440 volt. R is 6600 ohm. So this will cancel out, 10 will be cancel out. Okay, 10 will be there. 22 2 ja, 22 3 ja. So we have 2 by 30 and finally it will be 1 by 15 ampere. Okay, so this is okay. Remember, this will be small letter because we are writing the full name of the scientist. AMPRE. Okay, so this is the current in the circuit. So this current here is 1 by 15 ampere. Now we have got the current. Same current will be through this resistance. Same current will be through this resistance 1 by 15 ampere. So now we can easily calculate what is the voltage across it. So we are going to calculate. Let me erase it because let me erase it. Okay. Oh, or should I left it? So V2 we can calculate. We know V is equal to IR. For this resistance, voltage across it. We are going to calculate. I is 1 by 15 and R is 4400. Okay. Now on calculating, if you calculate this, it will be. Wait a minute. It will be 293.33. Okay. So voltage across it is 293.33. Okay. So certainly this is going to fuse. Why? Because its rating is only 220 and it is getting 293 volt. It means the fuse will burn. This fuse will burn. Okay. There is two fuse, first here and second here. First here, second here. It will burn. Now again calculate this one. Voltage across this one. So again using V1, we can calculate V1 is equal to IR. Means I is common for both. This will be R1, this will be R2. Okay. So 1 by 15 into 2200. Okay, 2200. Now when you calculate this, certainly because this is half of that, so voltage will also be half and it is approximately, let me calculate, 2200 divided by 1 divided by 15. Okay, it is 146.66. So this is 146.66. Now tell me one thing. Its voltage rating is 220, means maximum voltage it can tolerate is 220 and we are giving it 146. So certainly it will not fuse. The fuse will survive, but this fuse will burn. Okay, so this is the logic. Okay, this is 293, this is 146. I hope you got it. Okay, now let me solve the next question.